Hey y'all, this is going to go over Chapter 11, Part 2. Now, if you were in class today, we did all of what we're about to do in class. But what I'm going to do for you on here, on this video, is I'm going to actually let you see a problem that you haven't seen before. You're going to pause the video, you're going to work it out, and you're not going to unpause until you're totally done and you think you have the right answer. Like if that was the answer that you would have on the test, then that's whenever you would stop. Then you would unpause the video and you would see how I work it out, compare it to how you actually worked it out, and see if you got it right, see what you messed up on, and that way tomorrow on the actual test, you are more comfortable, you are more confident, and you actually know what to do and where you keep messing up, and you can fix that. Alright? So here's your first problem. The problem asks you to calculate the percent composition of ethane, and they actually gave you the formula. Now, I will tell you this. On the test tomorrow, I will give you problems that will not give you this formula. Now, obviously, with ethane, you have to have the formula because you haven't learned how to come up with that yet. But you might have other problems that I'll show you in a little bit that you can come up with the compound, and you'll have to do that. So what I want you to do right now is I want you to look at this problem, use your periodic table, which I'll also put up here, use your periodic table, use your calculator, use your brain, and see if you can come up with the correct answer. I went ahead and put the periodic table there for you along with your question. That way you can look at it all together if you don't have your periodic table with you. So go ahead and take some time and figure that out. Alright, let's check your work. Calculate the percent composition of ethane, which is C2H6. Before you can even calculate the percent composition, you have to know the formula. And remember, I told you have to have that formula memorized because it's not given to you on your formula chart. So percent composition equals the mass of your element divided by the mass of your compound and you multiply that whole thing, the whole answer that you get, times 100%. They did not ask you for one specific element. They asked you for the whole percent composition. So what that means is you have to actually figure out the molar mass of that whole compound, and then you have to do two different problems. You have to find the percent composition of carbon and the percent composition of hydrogen. So what we're going to do is we're going to come up with the molar mass of the whole thing. So we know that carbon's molar mass is what? You have to go back, you have to look on the periodic table, and what you will find is that the molar mass of carbon is 12.011 grams. How many of those do we have in this? We have 2. So that equals, oops, I'm pushing all kinds of wrong things. So after you multiply those two things together, what you're going to get is you should get 24.022 grams. Then you have hydrogen. Hydrogen's molar mass, after you look it up on the periodic table, is 1.008 grams. In this compound, you have 6. So your molar mass for hydrogen in this compound is 6.048 grams. So now we have the mass of two different elements. We have the mass of our carbon, and we have the mass of our hydrogen. Those are two elements. And what we need to do now is we need to add these two together. So, oops, that's not a decimal, it's a 0. That is your molar mass of the compound. So now all you would do is you would divide this number by your compound, and you would divide this number by your compound, multiply by 100%, and then that's what you would get. Okay. Let's see what we can, let me do this. Okay. So for carbon, the percent of carbon, we have 2 carbons. We have the mass of 24.022 grams. We divide that by the total, which was 30.070 grams. You multiply that whole thing by 100%. And you will get 79.9%, because when you do percentages, you only need 3 sig figs. So that gives us the 3 sig figs. Now in my calculator, whenever I put it in there, it told me it was 79.886%. We went ahead and rounded that last 8 to a 9 because it needed to be rounded up. Okay, so now let's do hydrogen. Hydrogen's molar mass in this compound was 6.048 grams. And we need to divide that by 30.070 grams. Multiply the whole thing by 100%, and you will get 20.1%. Now, in class, we always talked about a way that you can check your answers. Well, here's a way that you can check your answers. What you have to do is you have to add these up and add these 2 percentages up and see if they equal to 100%. When we add these 2 percentages up, what do we get? You should get 100% exactly. Now, like what we saw in class, sometimes whenever we round, we can mess up this right here. So sometimes you'll get 99.99%, that's close enough. Sometimes you'll get 100.1%, still close enough. It's whenever you get 97% that you have to start worrying, or 95 or 105. That's whenever you go back and check your work. Okay, let's try another one. Alright, this one says to calculate the mass of carbon in 5.2 grams of butane. What you need to know is what butane is, so I'm going to go ahead and give that to you. Butane is C4H10. Go ahead and try. Alright, C4H10, and we have 5.2 grams of it. Like what we saw in class today, do we care about how many grams we have of it, or do we care about the molar mass of it? I am hoping you're saying molar mass, and I'm hoping that the first step that you did was get rid of this, because that's just extra stuff in there that people throw in just to try to throw you off. But don't let it throw you off, because all you need to do is use the molar mass. So just like the last one, what we need to do is we need to find the molar mass of our whole compound. So we have carbon. Carbon's molar mass, after you look it up on the periodic table, you will find to be 12.011 grams. And how many of those do we have? We have 4. So that means that when we multiply that together, the molar mass of carbon in our compound is equal to 48.044 grams. And then you need to do the same thing for hydrogen. Hydrogen, we have 1.008 grams as its molar mass. We have 10 of those. So we have 10.08 grams of hydrogen. Now, the next step is to add those 2 masses together. After you add those 2 masses together, what you're going to come up with is 58.124 grams. This is the mass of our compound. You go back, you look in the problem, and you should notice that it's not asking for each individual element's percent composition. It is only asking for carbons in this one. So you kind of got lucky. Instead of actually doing both of these, you're only concerned with carbon, which is this one,